Welcome to my YouTube channel. In this video we will see benzilic acid rearrangement. In the content we will see principal reaction and its mechanism. Principle of benzilic acid rearrangement. It is a base catalyzed reaction that converts 1,2-diketone, that is benzil, we will take a benzil, into alpha hydroxy carboxylic acid, that is benzilic acid. Now we will see the reaction and we will understand the principle of a reaction. This is a structure of an benzil. Benzil, it is base catalyzed reaction. So here we are utilizing base, a strong base that converts 1,2-diketones. Why it is called 1,2-diketones? Carbon number 1 and 2, or we can number it from this side also 1, 2. It is diketone. So this complete structure it is called of an benzil. Benzilic acid. Benzilic acid. So here we have written that alpha hydroxy. Alpha hydroxy principal functional group in this reaction it is carboxylic acid. So this and pertaining to it, this will be an alpha carbon atom, alpha. So alpha hydroxy, it is having a substitution of an hydroxy on the alpha carbon, and remaining part that is carboxylic acid. So general, it is having two functional group, that is carboxylic acid and alcohol, and this structure it is called benzilic acid. So this is the reaction for benzilic acid rearrangement, where benzil is converted into an benzilic acid. It means 1,2-diketones are being converted into an alpha hydroxy carboxylic acid, and it is in the presence of an NaOH. So base it acts as a catalyst in this reaction. For this reaction you should understand some basics, it belongs to the class migration to electron deficient carbon. In the mechanism we will understand how this migration to an electron deficient carbon it takes place. What is electron deficient carbon? Electron deficient carbon, it means it is a carbocation. So plus charge it indicates that it is an electron deficient. Next thing that you have to understand, see each molecule it tries to complete the octet. Here there are 2 electrons in the each bond. So there are 2 electrons in the each bond. It means there are total 8 electrons in the outer shell, and that is how each atom it completes an octet. Now here we will have oxygen. So in case of an oxygen it is having a valency of an 2, and the total electrons they are 8, and 2 of them there are 2 lone pairs of an electron. It is a pair of electron. It means there are 4 electrons, and these 4 electrons they are non-bonding electrons, and remaining these are called bonding electrons, and these 2 lone pair of electrons they are called non-bonding electrons. You will find that oxygen it is having only 1 bond, so it will have 3 lone pair of electrons, and it will have a negative charge. It means that 1 lone pair it can be available for an bonding. So total electrons they become 8 as every atom it tries to complete an octet. Now we will see the mechanism part. Here I will write, instead of this phenyl ring I will write pH for that purpose, so it will be easy to understand. So the first structure in the mechanism it is phenyl ring, and it is 1,2-diketones plus having phenyl ring. Here we are using NaOH, and it will generate a nucleophile. As we have discussed that when it generates a nucleophile, oxygen it will get a lone pair of electrons, means hydroxide ion, and there will be 3 lone pair of electrons available. Earlier it was only 2, so sodium has given its lone pair of electron, and it will attack electron deficient carbon. As soon as it attacks electron deficient carbon, so oxygen the pi bond between carbon and oxygen it will break, and the further structure it will be formed like this. The oxygen will have a negative charge, and there will be 3 lone pair of electrons, and remaining structure it will have OH, that is the nucleophile, and it will have only 2 lone pair of electrons now, because third one it is been utilized for a bond formation. After that, in the next step, the lone pair of electrons on the oxygen, it will come down and again it will form a pi bond, and after that the phenyl ring, it will attack the carbon, electron deficient carbon, and at the same time the carbon oxygen bond will break. So this, it becomes migration to electron deficient carbon, as phenyl ring it has been transferring to and migrating to an electron deficient carbon. Now oxygen will have a negative charge and there will be 3 lone pair of electrons. So one, it is coming from an pi bond. Remaining structure will be, so again there is a pi bond formation as we have discussed. So oxygen will have a new pi bond and the lone pair of electron, it will be utilized for a bond formation. Now there are only 2 lone pair of electrons on an oxygen. By mistake I have written 6, so make it corrected that there are only 2 lone pair of electrons on an oxygen. Now in the further structure, so this there will be an proton transfer. The lone pair of from an oxygen, it will donate a lone pair to an hydrogen, and there will be a proton transfer. So the further structure will be like this. The oxygen, it has donated 1 lone pair of electron towards the hydrogen. Now there will be only 2 lone pairs. Third one, it is utilized for an hydrogen purpose for bond formation. And this, it will form a carboxylate anion, because hydrogen has donated lone pair of electron towards the oxygen. Now in the next step, it will be addition of an proton. So proton will be added in the last step. The oxygen, it will donate a lone pair of electron towards the proton, and this will be the final structure. So carbon will have OH as it is shown in the earlier structure. After that, phenyl ring, and addition hydrogen which has been added to this oxygen. So one lone pair, it has been utilized for a bond formation with an hydrogen. So now there are only 2 lone pair of an electrons on an oxygen. So this is the final structure that we get. Whenever you will write this kind of a mechanism in the paper, so here you have to write the name of the steps. See, the first step, it is attack of a nucleophile. So attack of a nucleophile means the nucleophile which has been generated in the step. See here, the nucleophile which has been generated, so it attacks an electron deficient carbon. In the next step, migration of an phenyl group or phenyl ring, we can say. So this is the main important why this reaction, it has been classified under migration to an electron deficient carbon. So phenyl ring, it is taking the lone pair of electron with itself and it is migrating towards the electron deficient carbon. Next step is proton transfer. Here you can see that proton, it has been transferred. See this arrow, it indicates that it is donating an electron pair. So here it is donating electron pair, oxygen, it is donating an electron pair. And the third step, it is addition of proton. So here you can see the electron pair, it has been donated towards the hydrogen, and there will be addition of a proton. So this is one of an electron pair which has been utilized for a bond formation with the hydrogen. So here there were 3, now there are only 2 lone pair of electrons, and remaining they are electrons, they are in the bonded structure. Hope you like the video.